Okay, awesome. Well,
Let's get
welcome
rolling.
everybody.
Welcome.
This is episode 14 of season 2 of Tech Talk Tuesday. And if you're joining us for the first time, you can catch all the replays on YouTube, on the Baseline YouTube channel, which is Baseline Web Training, all one word, on YouTube. And what we're trying to strive for this year is to build this audience, to provide more content to more people. So if you have a friend, colleague, customer, client that you would like to invite to join us, they can sign up at baselinetechtalk.com and join us right here every Tuesday at 1 o'clock. Quick introductions. I'm Andy Humphrey, irrigation technology consultant. We have Dan Conger, our training manager, Chris Wright, VP of sales for Baseline. And today we're going to be talking about flow devices. Dan's got real product in his hands on his desk that we're going to review and look at and kind of go a little bit deeper into the different types of flow devices. So again, welcome, and let's turn it over to Dan.
Cool. Well, I remember back in season 1, we talked about learning flow, and there's a big assumption there. There's assumption that you've got a flow device, and it's so easy. I know I'm guilty of it, assuming everybody has a flow device, and we kind of thought it would be worth backing up a little bit and say, let's walk through some of the options that you have on flow, the physical flow devices, maybe talk about where each one fits in. But then, of course, the benefits, right, of having flow is all the management capabilities, all the alerts, all those things that there's so much you miss out if you don't have a flow device or a flow device set up,
Dan, what
or
are
a
we,
flow device configured.
And what are we starting to say right now? If you can't measure it, you can't manage it.
Right.
Wow.
Right.
That you just summarized like my.
You guys are going to be hearing more of that when it comes to our
this.
precip sensor, but that's
Nice.
Exactly. And I think it's also important too that the flow sensor technology is changing quickly, right? And it's evolving into different types of devices, and being able to conform with that and be able to interface with these new devices is important because they are getting, designed and specified on plans and getting installed in field. And there's some preferences around them. So we need to make sure that we're relevant and keeping up with it.
Beautiful. Yeah. So let me switch over my camera. I'm going to get my extra light here. There we go. And I want to show you that this first flow device that I have.
And Dan, should I spotlight
I think if
you,
I'm
or
sharing
you
it, spotlights it.
Okay. Actually, you are. Perfect.
Yeah, which is what we practice at real quick. So this first one is a Baseline PFS. It's a plastic flow sensor. And a couple things about this is a paddle style. Let me move my mic a little closer to me. It's a paddle style. So it's got the paddle wheel in there. Oh, look at that. Spins around, and that's going to send a pulse each time it spins. The other thing is our bicoder is built into the top of this with the LED lights there, right? So there is no external bicoder that's needed. It's connected in the 2-wire path, and as the water runs through there, it's going to send pulses back to the controller, but now it's translating that into information that the controller can read. So the PFS, there's also a BFS, which is also brass, but I've got the plastic one here, all the way up to 6-inch, right? So the smaller sizes are through, and then the larger sizes are going to be a saddle style that would mount into a pipe. So there's that traditional paddle wheel that we're used to.
Okay. So if you're using that, you've installed that on your main line or at a control point. How do you know if it's set up correctly?
Well, the nice thing about this is because it has that flow bicoder built into it, it's pre-programmed with the K value and the offset value. So once I bring this serial number in to the controller, I will be able to see in the control point settings that those values are in there and it's ready to roll. It's always a good idea, though, to do some sort of a reality check, right? Because I have seen times when K values are wrong and the flow value is not correct, not necessarily because someone's played around with it. That's actually not uncommon.
And Dan, is that the K value right there on the top of the T there?
Right. And I don't know if that's because I honestly don't know if I think it comes that way from the factory. And can anyone confirm that one? I should have the answer on that, but I don't.
It's been a little bit since I've taken one out of a bag.
I know, same here.
Yeah.
Oh.
It comes printed on it.
Okay, beautiful. Yeah, so K value of 0.322.
Yep.
And that will populate in as well.
Mm-hmm.
So what's cool about these is they're pretty darn affordable, right? They are a great, I mean, and they're durable. So I mean, PVC is the rating on this is quite high. I had a conversation with Nick earlier in the week, and he says, well, you know, using brass versus plastic. And I thought that was kind of an interesting conversation because the internals are exactly the same, right? So this insert and the O-ring are the same. And I didn't immediately find pressure ratings on them, but I know that the pressure rating on the seals are going to be the same, which is true of, you know, inline plastic with remote control valves. I think it's similar.
Mm-hmm. Yeah. Can you pull that out one more time, Dan?
Sure.
The insert, the paddle wheel. There's just something I wanted to mention that, you know, occasionally it's nice to, you know, maybe during blowout or such, just to examine the paddle wheel, make sure there's, you know, it's clean. There's nothing, you know, obstructing it and such. And I was on a site a number of years ago that they were complaining that there was no flow, right? That was the support question. We're not getting any flow readings. And, you know, the LED lights weren't flashing on the top, and there's some steps you can go through to troubleshoot it, but come to find out it had been removed. And if you look at that on the side of that insert, there is a rib that lines up with the T. So you can only put it in one like exact way. But if you're off a bit, you can kind of jam it in there and screw the lid down. And it was in there just a little bit crooked where the paddle wheel wasn't able to turn. So sometimes it's so very simple can often be overlooked because you look at the device and say, yeah, it's installed correctly.
It's interesting.
Top, you wouldn't have known the difference, right? Looking down on it.
Well, although
today, I did not realize that had that groove insert to put it in there. So I've learned something new today.
There's a little arrow, right? It doesn't show up quite in the light. There's this little area, little arrow of indicating the flow too. So that's built in as well. So there's a clue to look for. So that's going to line up with the flow on there.
Yep.
And then when water's flowing through that and it's connected to the controller, the lights should flash. So that's the visual test that there's water running through there.
Right. Okay. So as we get in the larger size, it'll be saddle, but I think the same impeller works on all those, which is why that K value becomes really important, right? That K value is going to translate those, let it know what size pipe this is in, and it'll get those values appropriately.
So is the K value for a 2-inch going to be different than the K value for a 1-inch?
Absolutely different. Absolutely different.
Like a conversion factor, right?
I think I've called it a translation or a conversion factor. Yeah, absolutely. Right.
Mm-hmm. And it's also a function of the pulses per gallon or gallons per pulses, either gallons per pulse, either way. So sometimes you may know what that is. We'll talk about that later. But the K value and the pulses per gallon kind of are inverse or related to each other as well.
Correct. Yeah. Right. So some people just don't like plastic, and I don't see what the big deal about plastic is, but we do have a brass offering in this one. I don't have a brass BFS with me right now, but I do have a brass flow meter or BFM. And
I'm glad you have one of those. I didn't realize, but this is something that we need to talk about more because there's a lot of great use cases for this that we often overlook, and we forget to tell our customers that this product exists.
Yeah. So now this is actually going to be built more like a water meter. It's a disc style where there's a disc rotating through there versus a paddle wheel. Because if I pull it apart and you look straight down the bore, you wouldn't see the paddle wheel, but it's a rotating disc in here, and it's going to have that same analog reading, right? So we could walk out to this one and see what the current flow is without the controller. Whereas this guy, there's no interface on it at all. It's all the interface is 100% at the controller. And then we have a bicoder that's attached to that, and that's pre-installed. And because there's a bicoder that's ready to connect into the 2-wire path, that's pre-programmed as well. So this is the BFM, which brass flow meter.
Mm-hmm. Yeah. And there are occasions when you want a physical reading. You want to be able to walk out there, with your own eyes, record a value, outside of recording at the controller, or have a third party record it without needing access to the control system. And so that's why I guess I said this is often overlooked because of that. It's a great in-field option.
Yeah, if you've got a community where you've got mainline for common areas, and then you've got a secondary mainline that's going on to a private property, and you want to account for the water that's being used on that property off of your mainline, that's a great unit to install to do that.
So essentially a sub-meter, right? Yeah. Mm-hmm. And for my water conservation days, that's all we had, right? Is we just had this visual representation where you could go out and read it. But now we've got the best of both worlds. We've got visual representation and
technology didn't really exist in the 40s, Dan.
Hey, wait a minute.
Yeah, and thinking about that, Chris, I think that's actually a conversation I had recently with an irrigation designer. Was that exact scenario with another building accessing the water from a building upstream, and they didn't want to control that sub meter.
Yep,
it wasn't a control point. They just wanted to record the data. So they could sub out the billing, at the end of the month, at the end of the quarter, end of the year. And I suggested this because then they could walk out to the field and just take a hand note anytime they want to without making a phone call or accessing the computer. And with it being downstream as just a recording device, there's no need for flow stations and sub-metering and all that config.
Right. Well, and sometimes it isn't about bills, and it might just be about what's somebody else using. So if I have a irrigation system and I'm on the line for the water budget, but 20,000 gallons a month gets used by the building and the shop, I want, even if they're not paying for it, I just want to be able to account for it in my records that I'm producing for whoever I answer to.
Sure. Unique case for it also would be if you've got pond fill or something, water feature on property, and you want to know how much water is being put into that feature on a refill basis. You can meter the water going into it.
Nice. So on this meter design with this register, I've got a beast here. So give me just a moment. I'm going to bring that one over.
Yep. And then while you're doing that particular meter head, I believe, is called a photodiode. There are multiple meter options. So if you have an existing meter and you want to retrofit it to a baseline system, we do recommend the photodiode output meter head, and they can easily be replaced. You just unscrew that black kind of cover, and that meter head just pops off and it's completely sealed. So it's not like anything leaks out. It's just sitting on top of there magnetically.
So this is a BHM. This is a brass hydrometer, 1.5 through 4 inch. The 4 inch, man, I'd have to go work out a little bit before I move that around. Same register style with the disc style. But what's unique about this one is it's got the disc style flow recorder and flow device in here, but it also has a master valve assembly in it, right? So we've got one bicoder to read flow that's connected to the register, just like the BFM. But then I've also got another master valve connected to the solenoid for the master valve. So that's we can actually have two devices in one. And I think what has always impressed me about a hydrometer or a BHM is the ability to fit in very compact places, right? So when we'll talk about setup in a little bit, but you got to have clear pipe diameters depending upon the device itself, and to allow that flow to stabilize before it moves through. Not necessarily the case with this, right? We can shove this into very compact areas for retrofits.
Mm-hmm.
Yep.
Because of the horizontal turbine that's in there. If you think about that paddle wheel, water can, sort of scoot by, for lack of a better word, but on the horizontal turbine, it doesn't need that stream, straightening. It essentially has stream straightening in it.
Right. So available, normally open, normally closed, depending upon the master valve you've configuration you want.
How can you tell if it's normally closed or normally open just by looking at it?
The porting on the tubing.
Good.
Go on.
It either ports to atmosphere or it ports internally.
So which is which?
You tell me, Chris.
He just wants to watch us twist. Okay, but good.
So this is a good question because oftentimes it's unknown, right? But that configuration you have there is normally closed, right? Because the tubing coming off the top of the solenoid goes back into the bottom of the body of the hydrometer, right?
Okay.
If that tube were to vent to atmosphere shortly after it comes off the top of the solenoid, then it would be normally open.
Oh, interesting. Okay.
Which would mean what?
Oh.
If it's in a room, it'll squirt a little water, right? If it activates.
Right. Yep. Exactly. Okay. So always a good indicator if you open a box and don't know if it's normally open or normally closed. Look at the tubing off the top of the solenoid to verify.
Yeah, okay.
And then Dan,
cool.
Can you rotate it a little bit and see if we can see the toggle switch that's on there? Because that's another important sort of capability of the device. You can see there, and actually your camera's working well. I can actually read the words. It says open, close, and auto.
Yep. So where do we want it if we're utilizing it? If it's in the open position, then what's it going to do?
It's just going to run.
It's open. It's flowing water.
Whether it's a normally closed or a normally open, right?
Right.
Yep.
So if you put it to closed, then it'll obviously close, which means it won't allow the diaphragm to open. And if it's an auto, then that means that it's being automated by the system and managing and monitoring the flow based on the design flows and operation programmed in the controller.
Right. No, that's a good point, because I have seen users set this to open when they think I've got a normally open master valve. Let me set this to open. I have a normally closed. Let me set it to closed. And really the better way after hearing you say that is it's permanently open, permanently closed, or auto.
I like that.
Yep.
Yeah. And
all right. So Jim White threw into the chat a very good point. I was going to bring it up already, but there's a very small, fragile brass lever located on a hydrometer also.
Yep. Turn that down to the solenoid, Dan. It's right under the red portion. There you go.
So
can you move that over, Dan, so we can get a better look?
There you go.
There.
Yeah. So this guy, I could see how that could.
So that's your manual bleed, right?
Mm-hmm.
So you can switch that up to open up the solenoid, allow it to open too, just like you would on turning the solenoid on a normal valve, irrigation valve.
Okay. Mm-hmm. Good deal.
Yep.
There's very fragile. You need to it helps to exercise it periodically as well. Just go and turn it as a maintenance principle, so it doesn't jam up or get caught up. Because if it jams up and you force it, then you can break it off, and then you got a problem.
Yep. As well as the plastic tube fittings. You know, you'd be surprised how many times somebody drops one of these or hits it with something and breaks a fitting.
Because these fittings are plastic on brass. Yeah,
that's right.
Awesome. So
I think the most important question of all regarding that device is it a hydrometer or a hydrometer?
Oh! This is a beer question. I know this one. This is a hydrometer.
You know, it's a water question and a beer question.
It's a hydrometer, not a hydrometer.
Yep.
Although they're spelled the same.
Yes,
okay.
But phonetically,
okay,
potable
is not measuring the viscosity of a solution.
Okay,
right.
so
There I said.
I've got another device that can be used to measure flow, and this is a CP-PFS, control point PFS. So this has a plastic flow sensor in here, the same one that we saw before, that PFS with the built-in bicoder. Has a pressure transducer built in here, and then we've got a master valve bicoder. So we need to add our own. We could add our own master valve onto the leads here, and then we've got the pressure bicoder. So we've got a capability for pressure, flow, and master valve all together with one single 2-wire output, which is what we got right here. One single 2-wire connection. So 1 inch, 1.5 inch, and 2 inch. So piece of hardware where we've combined everything together. You can have those items separate, with our control point technology, or they can be combined together as they are in here. But I think this was worth mentioning, that it's another way to bring in that flow and master valve management connected to the 2-wire.
Yep. And then keep in mind too, I think we'll get into this on maybe the next product you bring out. These devices are 2-wire devices, right? However, if you have a conventional system and you don't have a 2-wire in the field, you're going to connect it to the 2-wire port of the controller.
Correct.
And so what we're talking about here applies to conventional wire and 2-wire. It's just that if it's conventional, you have to run the wire directly into the controller.
Right. Yeah. Now, you, Chris and Andy, you guys have seen a lot of other industry devices that. What are some of the other flow devices do you see that Baseline currently doesn't offer?
Doesn't offer as a product,
or
with a part number. Yeah. There's many different, manufacturers of flow sensors, and some are very, established in the industry. There's a lot of pre-existing meters and flow sensors that are out there. I think the thing that's important to remember is that if it provides a pulse output, then we're able to interface with it. With either the 5308 or the 5309 flow decoder.
Right. So they look identical. So here's the 5309 flow bicoder. Well, I take that back. They look very, very similar. So this one has the purple wire is kind of the big one on the 5309.
Can you separate those so we can see the wires, Dan?
Sure.
Not the 2-wire side of the decoder, but they're kind of the wires are crossed. It's tough to see.
I see. Okay, so here we go.
It looks like a duck, but it doesn't sound like a duck, right? So
and then
there's a difference.
Just down where it connects to the decoder, I think, Dan, if you could just separate at the black base.
I see
there.
what we're doing.
Right there. Let's take a look.
So this is
what we have.
So we got a 5309 here, and then somebody thought it was a good idea to. Oh, that'll still work. There's a 5308. So we've got some similar color wires. I've got a blue wire versus a purple wire. That's probably the biggest difference between 5308 and a 5309. So 2 different flow bicoders. And here, the reason I wanted to bring these up and the reason I asked that leading question for Chris is we can connect with most flow devices on the market. So you have a device that's more sophisticated that we don't offer. So an ultrasonic or a mag meter style, we don't currently offer that. You want to interface with those, or you have an existing flow device in the ground or a flow device that you like better. Either of these flow devices.
Or a pump station that we want to share the flow with.
That's true.
Yeah, exactly.
So flow output.
That's a very common occurrence. Why add another flow device when we can just couple on to the output? So you can check with your pump station manufacturer and ask them to provide another output for us.
Right. Okay. So the question that we were kind of working on, and the burning question is, when do I use a 5308 and when do I use a 5309? Okay, let's see if I got this. And then so 5308 is going to be for a lot of the meters that don't need power. So that's going to be most pulsed output. Now this one already has a flow bicoder in it, but if I have a paddle style that doesn't need, paddle style that doesn't need any additional power for it, the 5308 is going to cover it for many, many circumstances. but devices that need power that are not self-powered.
Most like, yeah.
Majority.
Most
Currently.
Devices are that 5308.
Yeah,
Right.
I would say that's
the most installed devices now, but moving forward, there's, the technology is evolving and we're getting more and more ultrasonic or magmeter type devices designed and specified. So those devices may or may not require a power supply to it.
so.
Right?
This is the magic, right? On the 5309 is that purple lead that's providing power to the external device. So
How much power?
12 volts. And what was it? What did we say? 50 milliamps? So it's
50 milliamp, 12 volt with 1000 volts of isolation.
Oh, wait, that's not all. Operators are standing by. Yeah, so this is for devices that are not self-powered. This purple lead is going to ultimately that. Now, how do you know if your device is self-powered or not? Well, you got to dig in to the manufacturer's information, right? Because we don't know all the different devices in there. So there's going to be a little bit of research on there. We may know if it's a common one. We might say, oh yeah, you've got this device. Yeah, that's definitely this. Or we may say, I don't know. You got to do some.
It's easier for baseline to talk about baseline devices than it is for baseline to talk about someone else's device.
Because we can talk.
There is an ultrasonic meter that is gaining a lot of traction in the market. The FlowMec ultrasonic meter. We can interface with it with the 5308 Flow Decoder.
Right. Yeah. Right. So when ultrasonic is not necessarily a dividing line between the two, because as you just mentioned, that one is self-powered and doesn't require it. So this works. Whereas some of the more established ultrasonic meters must have the 5309.
Right. Exactly. Okay. So with that all being said, nice question came in as we're running out of time. Are we able to provide a low flow bypass on a large volume water source along with a larger flow meter for the full volume? Example, 12-inch main at 1,000 gallons per hour or per minute. The answer is yes, and absolutely yes. So we've installed that configuration on a number of projects. We've even done if you remember the episode with Tracy Shields, we've done a triple bypass where we had an 8-inch, 4-inch, and 1-inch or inch and a half, I believe. But we've also got sites that have 6-inch and 2-inch bypass. So yes, for sites that have large volume water and may have zones that have lower flows that may be below the resolution of a larger flow sensor, we can have a bypass scenario. So we do have the resolution needed for those lower flow zones.
Mm-hmm. Yeah. And that kind of couples together with potentially reading that on a pump station. We had a question here about reading from a pump station. And from my experience, you can't just take the wires and couple it onto that other device. It needs to be like isolated separately. So there's, I believe, a device called an optocoupler that will take the signal, isolate it to a secondary output, and then our decoder would go on that secondary output.
Right. Yep. Exactly. All right. That was a lot of information.
It was, and the 30 minutes, as always, goes by really quick.
Yeah, we've come to the end. What do we have on tap for next week? We decided.
Yeah, we're going to talk about running multiple zones at once, or what we call zone concurrency, and we're going to basically take some challenging water windows that we talked about way back in season 1, and we're going to expand on that a little bit, a fair amount.
So. Awesome.
This ties into Baseline's, watering algorithm, right? It's not a calculation we're going to talk about. It's the AI under the hood that powers this. So
beautiful.
Going to be beating.
Awesome. Well, once again, everybody, glad to see you online with us on Tuesday morning, afternoon, wherever you may be in the country. But we think it's the best 30 minutes of the week. hopefully you do as well. Again, as Andy mentioned, if you've got colleagues or associates that you think could benefit from our content, please share with them the register or the link to register to Tech Talk Tuesday. And remember that all of the episodes are recorded and available on YouTube. So appreciate you all making me a star. I am a YouTuber, technically, if you think about it, right? As are you all, too. Yes. So go out, have a great week. Enjoy your startups. And we're here to support you. And we look forward to see you next week. See you later.
Yep. Thanks, guys. See you next week.